Welcome to the Structural Engineering Podcast.
We're your hosts, Zach and Max, structural engineers passionate about unraveling the complexities of our architectural wonders.
Whether you're a seasoned professional, an aspiring engineer, or simply fascinated by the science behind skyscrapers and bridges, you've come to the right place.
In each episode, we bring you insightful interviews with leading professionals.
So grab your hard hat,
or maybe your calculator,
sharpen your pencils, and get ready to explore the fascinating world of structural engineering. This is
the Structural Engineering Podcast.
This week's episode, I had some real learning to do, and lucky for me, our guest Colin Moriarty was happy to teach me all about this topic. We're talking concrete, but this isn't run-of-the-mill concrete, something I'd rank myself as medium at anyway. This is ultra-high-performance concrete, UHPC. Now, you'll see in my first questions that I just can't shake the concrete similarity, as if this is a high compressive strength concrete. It's not. These are certainly my words and my opinion, but to me this feels like a new material and one that I want to learn all about. UHPC is so much more than cast in place. It has ductility, compressive strength around 22,000 psi, a flexural strength around 3,000 psi, and absolute resistance to the freeze-thaw cycle. The mix for UHPC is aggregate, much closer to sand in scale, cement, SCMs, and more often than not, plenty of steel fiber strands, which help provide the ductility capacity. Also, for this topic, we had a lot of learning to do, and lucky for us, we were able to talk to an engineer and someone at the facility and construction side. So we'll have 2 episodes back-to-back here. Pull up a chair on your old-fashioned concrete slab-on-grade floor, and let's learn about UHPC. Colin, thanks for joining us on the show. Could you introduce yourself and maybe give us a little background info?
Yeah, I graduated from the University of Minnesota in 1991 and went to work for the South Dakota DOT as a bridge designer for 5.5 years and ended up moving from Pierre, South Dakota to Sioux Falls to join Gage Brothers Concrete Products. I was looking for a consulting engineering firm, and I had no idea how much engineering gets done at a precast plant. But I still, when people ask how long I've been in precast, I really think it's more like 33 years because when I was at the DOT, all of our new bridges were precast concrete girders. We got scolded by the steel people for designing so many precast concrete girders, and so the chief bridge engineer said, "We have the people to do it. We'll work weekends. We're going to design." We did alternate design. We did side-by-side designs for steel and concrete for probably 4 of the years I was there. And I think we bid 18 to 20 major projects, and only one of them went steel. So after that,
Wow.
he said, we're going to go back to deciding when we want to be steel and when we want to be precast. So, and then I was, like I said, I was engineering manager at Gage Brothers for a very long time, and just decided I needed a change January of 2021. And my wife and I moved down here to Omaha to work with eConstruct. It seemed like an exciting opportunity because they have international presence and we do a wide range of projects here at eConstruct.
That's very exciting. I'm also impressed by the jump back and forth between what would be sort of horizontal structures and vertical structures in the traditional sense. I think about these as separate, but it's the same physics. They're not really separate. So,
well, it's interesting because when I was hired at eConstruct, I know that I was being introduced to the other partners as, hey, this guy was a bridge design engineer. Then he was a precaster. So he's got,
a little of both.
I hate to sell myself as a bridge engineer when I haven't been through the AASHTO guide in 24 years. I'm sure I could get back into it, but you have to be careful touting yourself as an expert at anything.
That's true. Well, today I'm going to be asking you about ultra high performance concrete.
Yes.
And we'll keep the expert word careful, but in my eyes you are, but we'll wait. So I'm going to use the acronym just for listeners. UHPC is the acronym and abbreviated version of ultra high performance concrete. It's a bit of a mouthful, so I'm just going to jump to that as we talk here. So I'm really starting my questions with the basics.
Yes.
And at the baseline here, what exactly is ultra high performance concrete, and how does it differ, or when does a strong concrete mix become ultra high performance?
Well, yeah, PCI commissioned eConstruct with some other consultants and partners to come up with a design guide where we set some baselines where it has to be very high strength, high durability concrete. Plus, we were looking for not only the high strength, but also the ductility that you don't usually see in concrete, because the idea is to use fibers to to offset your shear steel and to eliminate much of the reinforcing steel other than your main flexural reinforcement. So it's a highly refined microstructure and fiber reinforcement to achieve superior performance characteristics, high compressive strength, post-cracking tensile strength and ductility, and exceptional long-term durability in aggressive environments. The key to it is the particle packing. It is pretty much all fines. You only have you have no coarse aggregate. So you have fines, high cementitious, high amount of fiber, steel fibers, and a very fine sand, and and large doses of admixture.
Interesting. Okay. So it's a very different mix than the traditional concrete. And a fine aggregate, what size is that? Is that a quarter inch?
Yeah,
For anyone who wants the specific definition, ACI might say most fine aggregate is smaller than 3/8 of an inch. So I wasn't bad with my quarter guess. And Colin is very polite with my ignorance. But as I said before, this isn't just high strength mix. The changes go much farther than that.
the coarsest aggregate used is a very fine sand. I don't have like a sieve
Really?
number for you, but the silica fume is the finest material put in, and then a fine sand is the coarsest. So it's
Yeah.
they're very close together in their gradation. It's interesting that you say it when we try not to discourage the growth of UHPC by scaring people with it's something completely different, but it's like the same things we've been working with for 30 years and just combined in a matter using the synergy of what we already know about these materials to have them make something special.
Yeah, I have a lot to learn here. And I actually want to bring up a question on one of the things you mentioned from the get-go is that we have the flexural steel. Now, I'm definitely jumping ahead here, but we don't need the reinforcing steel from a crack standpoint. Is that so? It's basically just flexural steel, just strength steel.
There's very little other steel other than the main flexural reinforcement. You'll have a beam with your pre-stress strands, and to make it efficient, it's a lot of pre-stress force because a very high strength concrete like this can accommodate a large pre-stress force. And then we have put some reinforcing steel at the bearing, but from end to end, there is no shear steel. And I hate to say there's no shear steel. It's the shear steel is the fibers.
Yeah.
The fibers are
Is
0.2
this
millimeter diameter by 12 millimeter long, and they're very high strength fibers.
okay? 12 millimeter, half an inch.
And 0.2 millimeters in diameter, so very fine also.
Okay, I'm excellent. I'm not even close. What is the code that runs this category? I assume this is not our typical ACI that me engineer would have on our desk, the 318.
Yeah, AASHTO has a guide for UHPC concrete, and it's a little bit different definition than what I'll be talking about today because, like I said, eConstruct was part of developing a design guide for UHPC, and they have a published materials document and a published design guide. Yet I wouldn't say that it's codified. That's our guiding documents anyway.
I did actually want to ask about supplementary cementitious materials, SCMs. Is there a place for that in UHPC?
Yeah, the like I said, it's a very rich mix of cementitious material, and that's Portland cement, silica fume, slag, and other pozzolans. SCMs are very important to the mix. And, I think it's important to note that over the years, for many years, there have been very high strength, very there have been proprietary high strength mixes out there sold by different materials companies, and I think the goal of the PCI project and the initiative was to implement UHPC and work with producers to take your local materials and come up with your own UHPC mix. So it's less relying on we're trying to grow the industry by not relying simply on a proprietary mix, being able to do some testing and come up with your own mix.
Okay, yeah, that makes sense. I think I was thinking in my head that like we have this basic mix with traditional cement and then we could modify a little bit with SCMs, but it's not exactly you're aiming for a performance, not
Yeah.
here's your ingredients, that's what you get.
Yes.
How about aggregate? So I know you've already mentioned this one, but does the aggregate need to be a specific strength? I know these are very small, but is it difficult to find the aggregate?
I don't think it's going to be difficult to find the aggregate. Silica sand is the coarse aggregate, and that's a very common sand that's used. And like I think I mentioned before, the key to these mixes are particle packing, with so many fines packed in so closely. That's how we achieve that particle packing. But I really don't think silica sand is a challenge for anyone to get.
So I've seen UHPC mostly used for precast elements, or I've seen example projects. Is this something that we can do in cast in place construction, or is this only precast?
I thought that was interesting when I was reading through your leading questions, that it seemed like quite a few of them were geared. There's one about site considerations where it just threw me for a loop, because I honestly haven't considered that much about the use of UHPC in cast in place applications, mostly because the quality control has to be closer, has to be held closely, and it's very important. The mixed temperatures in curing are tighter than for a traditional concrete mix. And I think, I'm not saying you could not do that with cast in place. It's just, I think especially the temperature, the heat of hydration is so strong that usually for a mix such as this, you put in up to half the water as ice. So that's it.
Wow.
To help control the heat of hydration. Yes. I
Wow,
think I've
that's
got it in my
crazy.
notes here. The heat of hydration is
This concrete is 60 to 80 degrees in placement, so quite warm. Is cure time different?
not necessarily. Curing methods are a little bit different. Your curing methods have to be specifically designed to contain the water, which any curing methods are, but you just may have to do more than conventional concrete to contain the moisture in the mix. You don't want a rapid moisture loss, as with any concrete mix, but really cure times are not a whole lot different. I mean, the PCI research project, they use 10,000 psi as the release strength, but it can be largely variable. But geared toward 10,000 or 10 KSI or 10,000 PSI, just to make it practical that's what you should be able to get overnight or in 2 days.
Okay.
With a mix such as this.
Is the water a higher ratio? Just since you mentioned the water there, and I know we have a lot of fine elements, so the water will distribute a little differently than around a 3/4 inch piece of aggregate. Is water ratio way higher?
No, I don't. It's actually a low water cement ratio.
Really?
So I guess, when you're talking about water cement ratio, if you have a lot, if you have much more cementitious material, you're going to have more water. But the ratio is actually lower than what it would be for a standard mix.
It's good. Yeah, sorry. It's a good point. It's like, although it may be more water, if the water cement ratio is lower.
Yes.
Yeah.
Right.
Yes. Tell me a little bit about the cost implications here. We talked about this a little bit before, but when you're considering this as an option, say you have a beam that could be half the size if it's ultra high performance, at what point do you cross the line of this is advantageous to look at?
Well, and that's a great question because your cost is is going to be roughly based around one third is going to be in fibers, one third in cementitious materials, and one third in the admixtures. The silica, sand, and water are very cheap. So it's really those those three things making up the lion's share of your cost, and it's going to run $1,000, $1,200 a cubic yard, which is much more than what many producers are paying for their standard mix. But the comparison needs to be made in structural system, like you said. You're going to have smaller sections. Number one, you're also going to have if you can do greater spans, what's the value in taking out some columns and taking out some other structure? There's also, you have to consider the durability and lifespan of the structure. Also, if you're talking about a 300-year design life for a UHPC member, then if you life cycle cost it, it becomes the less expensive option very quickly.
Yeah. Okay. And actually, since you expressed the 300-year life term, I have some curiosity on some of the applications that we have with UHPC that we wouldn't exactly have with traditional concrete. What are some of the unique applications you've seen with UHPC that you or are you
Well,
seeing concrete in places that you didn't see before?
uh, really, I think most of what's been done with UHPC has been transportation. There have been tremendous strides in transportation, especially around the globe. Less in the United States, although the Federal Highway built a UHPC bridge in Iowa quite a few years ago, still performing well. I think moving forward, you can use it to get more open floor plans with your structural members. So that it'd be an improvement in structural concrete. But there's also one application that we see it quite a bit. In a very high strength mix like this, your your bar development lengths are going to be very small, very short. 8 times bar diameter, things like that. And your strand development. That's why we've seen it in already in transportation structures for repairs. They've done some terrific repairs with UHPC. Um, I see a future with this product in architectural precast because you're we're already looking at some projects where we make a thin veneer with you have a 1.5 inch veneer of concrete. The trick is designing built up sections for the connections. But that, it also makes for easier to handle, much lighter veneer also.
Yeah, I assume it can be much thinner to pick it
Yeah.
up. So
Because I mean, right now we've proved that you can cast UHPC as a bright white. We've got great smooth bright white mixes. But as you can imagine, what's typically done with architectural precast concrete, you texture the surface. Well, this surface is very difficult to texture. So we have to look at how can we texture the surface. And we're doing experiments overseas right now with adding color to the mix and trying to not affect UHPC properties with color added.
and I wonder, do the fibers influence the finishability? I know with macro and microfibers, it sometimes comes up as a question.
Yeah,
Can it be architecturally exposed, I guess?
yeah, you certainly can. There's also two different. You have your steel fibers, which we consider our baseline UHPC, but we've also worked with polypropylene fibers. I made a note of the different materials. There's polypropylene, polyvinyl alcohol, high performance polyethylene. Those different materials are being tested as fibers also, and because I think you wouldn't. Although I've seen UHPC with steel fibers, you wouldn't want a steel fiber exposed to the exterior and cause a ruster or anything like that.
Yeah. Yeah. So I wonder what you've seen for what research is being done for UHPC, sort of on a university level or businesses, but what might be coming up in the near future.
Yeah, I have not heard about a whole lot of research going on in the field. I think that I think research on non-metallic fibers would be a good avenue to go. And we have done a lot of transportation structures where the emphasis on fire resistivity is not as strong. When you get into commercial structures, I think there should be more research on the fire resistivity of UHPC also.
Yeah. Okay. So I want to ask about sustainability in UHPC and
Yeah.
how this might compare to traditional concrete and even if it's a little worse in sustainability standpoint, if it's far better in a strength standpoint, maybe we lean to UHPC.
I think that your sustainability footprint will be greater up front. Once again, like the cost. That's why it's almost like you need visionary people to use this material because it'll both be probably more expensive or a wash up front. But with your life expectancy being much longer, if you use a life cycle cost, it should be more sustainable because you are going to use more, even with a smaller section, you're probably going to use at least, if not more, cementitious material than a traditional concrete structure because there's so much cementitious material in these mixes.
Yeah, I think the lifespan makes a lot of sense there. That if it can be around for 300 years, you're dividing by a different number for your,
Yeah.
I don't know, CO2 equivalent by time. You touched on this one too. Is if you're integrating this to another structure, we look at rebar codes in ACI 318. A lot of them are limited by a minimum factor. I would assume that most of the time that is our limiting number for any embedment length or lap splice or something. The strength is just so high that we don't need that much.
Yeah. I mean, that's a good question. I mean, how does it affect like a 90-degree bend or a 180-degree bend? We know that the development strength is very short with UHPC, but then again, we didn't use a whole lot of reinforcement in both our test specimens or the real specimens that we've used so far. So there haven't, I thought it was really interesting in some of the test specimens that were tested in Chicago at Wisjani's lab. The Actually, some of the earlier cracking came in the specimens that they put transverse shear reinforcement in the specimen just to see what it would do. And it actually created a stress concentration there that was adverse to the performance of the material. So where you think you're being sort of a belt and suspenders, you're not doing the product a favor.
Huh. Yeah, I can imagine that. How long has UHPC been around to study, as a element that we're using?
Boy, that's a good question. I know that way back when I had just left the DOT for Gage Brothers, we did some. See, then again, it wasn't called UHPC; it was just high performance concrete. We did two bridges with I think it was 11,000 psi or 11 ksi mixes, and the DOT looked at how they would perform. I believe they've got to still be in service. They were interstate bridges, and like I said, I think it was well back in 2009 when Federal Highway did a true UHPC mix in a bridge girder job in Northwest Iowa. I know that overseas there have been quite a few bridge structures in Southeast Asia. I know that it's very popular, and but I don't have a real good history as far as how far it goes back.
Yeah, I'll have to take a little look at
It's
this.
almost like that's my anecdotal history, but it's not. I wouldn't call it a comprehensive history.
Luckily, the internet has the answers I'm looking for. So here's a little concrete fairy tale. Everyone knows concrete has been around since the Roman Empire, but we didn't develop Portland cement until the 1820s, and 30 short years later we had made it to reinforced concrete structures. The HPC term was coined in the 80s, with mixes up to 17,000 psi. This concrete was a bit brittle and fibers began being added, which is essentially what we think of as UHPC today. Those letters weren't used until 1994, with the first construction use being a 1997 pedestrian bridge. Thanks, Google.
You're welcome. Have fun with your concrete.
Almost as far as research kind of goes, for seismic use of this, of UHPC, what sort of research has been done there, or where do you see the UHPC being used with its increased ductility? With the fibers in there, I assume it doesn't fracture like traditional concrete does. Does it have a place in seismic use?
I do think there's an application for UHPC in seismic. I don't know that there's been any research, but like I said, the fact that it is a ductile material should lend itself well towards seismic applications. We had an important qualification of PCI UHPC is the requirement that your peak to cracking stress ratio is 1.25. So you have that initial crack, you should have strain hardening for another 25% of strength. And that's to prove your ductility, that you do not have a failure or a loss of strength after the first crack. It will continue its strain hardening for at least another 25%.
Interesting. Okay. And I don't have that much concrete use experience, but if we're looking at generally precast elements, what sort of system can we use from a precast standpoint in a seismic lateral force resisting system?
Yeah, no, it's a good question. And I guess I just wouldn't consider we talk about expertise, and I have not done a seismic system with UHPC. I don't know that anyone has. And, I would think that, around here, when seismic is not the number one consideration, we had, on the project that I worked on, we had traditional high strength concrete columns with a UHPC member spanning between them. Well, I would think that in a seismic application where that same kind of strength and ductility would be required out of your columns, you might cast columns as a UHPC member also to get that same strength and ductility.
Yeah, I could imagine this as a moment frame would be really a place to shine.
Yeah, I think it would be a challenge as a moment frame, because I know that you have to pay special consideration to shrinkage. You're going to have more shrinkage in as you would expect in a very high cementitious mix such as UHPC.
And I'm embarrassed I didn't ask this much earlier, but what is the strength that we actually are looking for in UHPC? And you said some of these numbers, but the range here, when do we get to UHPC?
The PCI UHPC guide was based around a minimum service compressive strength of 17.4 KSI, 17,400 KSI.
Wow.
So it's roughly, like a low strength, like half the strength of an A36, a very standard steel. I don't know what a common cast in place concrete strength is, probably about 4 KSI. So you're talking about a little over 4 times as much.
Wow. Okay. That's extremely strong.
Yeah.
Kind of exciting to see where this will go eventually. I don't actually know if this is actually one that will affect us from the structural engineering side, but is there any additional requirements for special inspections for UHPC, or is that not really codified yet?
No, I think it's the same. Like I say, you have these QC requirements with regard to your temperature. I don't think that it's the same QC that you would use for conventional concrete. You just have some different tests. You take a few more samples, and we do different tests.
What are those tests? And is it the same format of tests that traditional concrete would have, or do you need kind of a different lab to look at these?
No, that there are the typical machines you would find in a normal testing facility they are ASTM standards. The tests that are used to test UHPC. It's whereas you have your stress, which or compressive test, which everyone's familiar with, making cylinders and crushing them, but you also make small beams and test the ductility of the mix. I
But it's
believe those are pretty.
sort of a basic test that any concrete lab can perform
Yes.
without any issue.
Yes.
So if we're looking at regionality of this, is this specific to an area at all, or is this kind of encompassing the whole U.S. that if you were in whatever Washington or Florida, you could look at UHPC options and there's not really an issue there?
Yeah, I don't think it's specific to any region of the country at all. I think it is truly that was truly the goal of PCI with this research, was to look at local materials from all over the country and come up with a very straightforward set of mixes that use. I think everyone has some version of a fine sand that's a strong, a durable fine sand, and that's really all you need to get started.
Last couple very small questions, but I almost want to hit before I get into those. Is there anything about UHPC that you think is worth discussing, for the traditional structural engineer that is maybe looking at, or maybe not really heard about UHPC? What is critical to know?
Boy, that is a good question. I guess the guidelines of the UHPC project, that you have your service compressive strength. You have We don't really need to specify a release, but they had a release in their literature, but also the tensile properties per ASTM 1609. You have your minimum cracking stress at 1.5 KSI, your minimum peak stress at 2 KSI, and then your peak to cracking stress ratio of 1.25 to ensure that ductility. And then the minimum stress at deflection of L over 150 is equal to 3/4 of the first peak ductility. Now that sounds like a mouthful, but it's really it's creating this ductile concrete material that you can trust with being ductile after first crack and giving you the performance you're looking for.
Is this, if UHPC is traditionally calced by a concrete team, like the producers, and most of the people that listen to the show are the structural engineering category that, would maybe run a traditional concrete beam that's 4,000 F prime C and say, oh, it doesn't work. Let's make it much deeper. And it doesn't really cross their mind of like, if we do this precast UHPC element, we have this as an option. So I wonder how should people think about UHPC as we always have this option? Is there an element where you need the structure to be concrete and you need to span 30 feet and, some considerations? And I actually don't know how to ask that question.
No,
I guess,
I understand exactly where you're coming from. I think it's a great question. I think as a structural engineer, you can sit in your office and say, you know what, I'd like this to be shallower, and I'd like it to, have the ductile properties of UHPC. So I'm just going to draw it like that in my plans and say, write UHPC on it and be good. I think you have to get in touch with your local precast concrete producers and talk to them about their familiarity with UHPC, and see if they can, if they're equipped to, if they're set up to engage with UHPC. I mean, because I think most producers are very curious about it, but some of them haven't exactly embraced why do we need to change the typical projects we're doing right now.
yeah, I think material has so many possibilities, but I wonder that the traditional like me structural engineer, I have a toolkit of, here are my beams, concrete, steel, this is just what I have to use. And then it wouldn't even occur to me that like, well, I could look at this UHPC option and span much farther or much smaller and last much longer too. So it's hard to
Yes.
put that in place.
And I think that the commercial structure world doesn't look at design life as closely as the transportation world. And I think that's why. I mean, the idea that, they run the ASTM freeze thaw and the different durability tests you can run through ASTM on a concrete member. And if you extrapolate out the performance of UHPC, like I said earlier, 300 years, although, I don't think we've had one around for 300 years to know that it's going to last that long. But it's one of those things where if you have a concrete mix that is so impermeable that you're not going to have problems with the de-icing salts or the typical corrosion, you can see how attractive that is to a transportation owner.
Yeah, certainly. And I would assume that the rebar only in a tension point gives there's less points for water to get in and the rebar to rust or expand, contract, and then like the bonding layer to be an issue. If it's more of a homogeneous mix with fibers and then just rebar in the
Exactly.
tension, there's less to break apart.
Yes, exactly.
I'm gonna get to my last, which could be a quick question, but you've mentioned this a little bit before. How does UHPC perform in fire test? So compared to conventional concrete, what fire protection measures are typically employed to enhance the fire protection if needed?
Well, I mean, as you can imagine, when you're a mix comprised of a lot of steel fibers, it isn't as resistant to fire as traditional concrete can be. But there have been tests that prove that UHPC is much more resistant to fire with a polyethylene or some kind of a non-metallic fiber as a substitute. And so those have shown tremendous amount of promise. I think the holy grail is getting to that 3-hour fire rating with just steel fibers and non-metallic, a combination of steel fibers and non-metallic fibers.
Okay. Yeah, I think I have a lot more to learn about UHPC. For people that want to learn more, is there a resource that you'd recommend?
Yeah, I guess I would recommend the PCI design guide, and I could send you a link to those.
Yeah, I'll put the link in the show notes. Well, Colin, thank you very much for teaching
Yeah,
us a bit about UHPC, and we'll certainly do some more homework and talking with Joe later in this episode to learn about placement of this and continue our education.
yeah. Thanks for having me on.